morning. Today I'll be talking on bacterial transformation according to the practical we just concluded today in DNALC. So we started off with bacterial culture on LB agar. The bacteria we cultured was E. coli, and the reason we used E. coli was because it possesses only exons in its genome, which makes it easily manipulated. So on Wednesday, we cultured the E. coli on a plate and waited for 24 hours for growth. Now, after 24 hours, we are presented with two tubes for piglo positive and piglo negative. The piglo being the plasmid that we are working on for the bacterial transformation. Now, calcium chloride was added to both tubes. Calcium chloride is a transformation solution. After calcium chloride was added to both tubes, the plates that we inoculated 24 hours ago were collected from and added in each of the tubes, the piglo positive and the piglo negative, before the practical started. Now, after these two things were added, both of them were added, we are put inside ice containers, inside a container packed with ice, in order to maintain a certain temperature. Now, it was kept there for a period of about 20 minutes while we were being taught in class. Now, after this was done, the plasmid that we'll be working with was brought in and added to only the tube containing the piglo positive. Now, the reason this was done is because the piglo negative is supposed to function as a control to the bacterial transformation that will happen in the piglo positive tube. Now, after this was done, both tubes were carried in the bath into the water bath, and then they were heat shocked for 50 seconds at 42 degrees. And after this heat shock was done, it was transferred immediately into the ice bath again for 10 minutes. And after 10 minutes, we are given the two tubes to hold between our palms at room temperature in order to warm them up. Now, after the warming up was done, both tubes were added nutrient broth, that is the LB agar, which is also called nutrient broth, was added into both tubes to serve as a meal for the bacteria. According to how we are taught, it's supposed to be a palliative after heat shocking the bacteria. Now, after this was added, there are 4 agar plates prepared. Now, each of these agar plates, 2 are allocated to each of the tubes. Now, for the piglo positive tube, there were 2 plates, one containing the LB agar, the ampicillin gene, and then the arabinose sugar. Now, the purpose of adding the ampicillin gene was that we are trying to create ampicillin resistance in this agar. The plasmid we added earlier contained ampicillin resistant gene and a GFP gene, which is supposed to function as a marker gene to indicate the presence of the ampicillin resistance gene in the piglo positive tube. Now, this plasmid was not added into the piglo negative tube because that's supposed to serve as a control and does not require the plasmid because there's no bacterial transformation going on in the tube. Now, after this, the piglo positive tube, a wire loop was used to collect the bacteria on it and then inoculated into the plates containing the LB agar, the ampicillin gene, and then the arabinose sugar. The function of the arabinose sugar in this plate is to act as a switch for the GFP gene. So it either turns it on in its presence or turns it off in its absence. So now the piglo positive was streaked on the plate containing the LB, the ampicillin, and then the arabinose sugar. The second plate for the piglo positive contained only the LB agar and then ampicillin, while the other 2 plates for the piglo negative were for LB alone, and then the second plate was LB and the ampicillin. Now, the point of having LB and ampicillin for the piglo negative and LB and ampicillin for the piglo positive was for both of them to be comparison plates for the absorption of ampicillin resistance by the bacteria by transforming. Now, these plates were left in the incubator for 24 hours again, and the expected result was that there will be a glowing effect on the plates containing the arabinose sugar. That's the LB, the ampicillin, and then the arabinose sugar, because arabinose sugar turns on the GFP gene that was added in the plasmid earlier. Now, according to our results, there was a glowing effect. There was a green glowing effect under UV light in the plates containing the LB agar, the arabinose sugar, and ampicillin. And there was also growth of bacteria because the bacteria absorbed the ampicillin resistant gene in the plasmid. Now, on the other plates containing the LB gene, the LB agar, and the ampicillin gene. There was growth of bacteria, but there was no glowing effect because there was no arabinose sugar to turn on GFP gene in the bacteria. Now for the other two plates containing the piglo-negative, that's the LB plate, and then the plate containing the LB agar and the ampicillin. There was growth in the LB plate because it's the perfect growth conditions for bacteria, and there was no ampicillin to stop its growth. While on the other piglo-negative plates, where there was the LB agar and the ampicillin, there was no growth at all, because in as much as the LB agar is the perfect growth media for bacteria, the ampicillin, which is an antibiotic, hindered the growth. And that was the result of our practical. Thank you.